Right, if you look at the mark scheme for this question, you might find there's a bit of an error, unless I've managed to fix the file by then. So don't get confused if you find an extra pi over 2 in the mark scheme. Okay, so we've got a particle that's on a surface. Okay, here's our particle. It has mass m. It's at rest at point O between two walls, and the walls are 4 meters apart. So that means it's 2 meters either side. Read this question carefully because some people got the distance wrong, which makes your answers wrong later on. Right, so at t equals 0, we're going to project this particle with speed u, perpendicular to the walls, and this basically, if you read the whole question, the particle is just going to bounce back and forth. We've got the coefficient of restitution. Right, then they've given us the impulse from the first wall, and we want to find lambda. Okay, so impulse is change in momentum. So we've given us the impulse. What's our change in momentum going to be? So let's have a look. It's going to hit the wall like that. We know that the coefficient of restitution is the speed of separation. If I say after it hits, it speeds v over speed of approach. So we know 3/4 u is v. So its change in momentum. Well, after it's hit, it's going to have a velocity of 3/4 u. And that's going to be in the opposite direction to which it approached. So its change in momentum is mass, we've got the mass, times 3/4 u, plus the mass times u as it's changing direction. So we're going to add those. All the m's are going to cancel out, all the u's are going to cancel out. So you're going to get lambda is 7/4. Right, that was only 3 marks. So a slightly shorter question. What happens now? Right, well, it's going to, particle here is going to bounce against the first wall, turn around, bounce against the second wall, turn around, come back to O, and it's going to take 7 seconds to do that, and we want to find U. Now, we're going to be using speed, distance, and time here, but the speed's going to change every time it bounces. So we've got the start, we've got after bounce 1, we've got after bounce 2, and then work out the speed and the distance between all of these. So it starts off with speed u. It's going to travel 2 meters. It's going to travel 2 meters to hit the first wall. After bounce 1, we've already found out that its new velocity is 3/4 u, and it's going to spend 4 meters traveling until it gets back to the other wall. It's then going to bounce on the second wall. So after bounce 2, we're actually going to have this same expression here. Okay, so it's going to approach with velocity v, it's going to bounce back with velocity w, but we're going to have the same relationship because e is still 3/4, so that's going to be speed of separation over speed of approach, which means all I've got to do is do that my v is going to be 3/4 times 3/4 u. So this is now 9/16 u, and it's going to travel that for 2 meters. So we've gone 2 meters, 4 meters, 2 meters. Right, now we can combine all that, and we're trying to find the value of u. So remember our distance travelled, our displacement, is going to be our speed times the time we travel at that for. So that means that time is our distance divided by our speed. And let's combine all that. So time is 7 seconds. Our first section, our distance is 2 and our speed is u. Then we do our second section, and then we do our third section. Okay, now we're just going to solve that for you. And you should be able to get to u is 14 over 9.